All right, we are in chapter 12 on page 879, and we're going to talk about box plots. Our learning objective is I can draw and interpret box plots. So the first part of this is going to be spent, how do you draw and make a box plot? And then the second part is going to be interpreting a box plot. The real world link is about football. The table shows the number of touchdowns scored by each of the 16 teams in the National Football Conference in a recent year. Plot the scores on a line plot. So let's start off with 47. That would be between 46 and 48. 41, 35, 38, 28, 54, 49, 24, 49, there's another one, 44, 27, 34, 37, 44 again, 26, 36. Okay. All right, so now we need to find, let's start with finding the median. So if there are 16 pieces of data, we need to find what's in the middle. So 8 and 8, 1, 2, 3, 4, 5, 6, 7, 8. So what would be in the middle right here? 2, 3, 4, 5, 6, 7, 8. Between 37 and 38. Between 37 and 38, it's 37.5. So now the lower extreme, that's the smallest number, is 24. The highest number, the upper extreme, is 54. The first quartile, so we had 8 pieces of data here. So what's in the middle? Oh, and they wanted us to put a star on it, didn't they? Star, star, star. So in between 28 and 34, right in the middle would be here, which would be 31. And the third quartile, 1, 2, 3, 4, 1, 2, 3, 4. So it would be between 47 and 44. So 44 plus 47 divided by 2. $45.5. So that would be about here. Okay, so we've got our starred spots. We have our data. What percent of the teams scored less than 31 touchdowns? So 31, less than 31. 4 out of 16. That would be this bottom 25%, right? Because 25, 50, 75, 100%. So that would be 25% down there. And what percent of the teams scored more than 37.5? So what, this was what, 8 teams? 4, 5, 6, 7, 8. So that right there is half of the teams. And what percent is half? 50%. So what we're going to look at is, how can we plot this data in a different way that looks like this? How can we plot it like that? And then how can we look at the different percents? This percent was below this much was above, how spread out was the data, all that good stuff when we interpret box plots. Now, to construct a box plot, you have to know what all of the different points mean. So let's go through this. A box plot or box and whisker plot, so sometimes it's called box and then these little whiskers, uses a number line to show the distribution of a set of data by using the median, quartiles, and extreme values. A box is drawn around the quartile values, and the whiskers extend from each quartile to the extremes, so the lowest and the highest data. Now, the outliers are different though, so it only goes to the data that's not an outlier. The outlier is marked with this little star, if there is an outlier. The median is marked with a vertical line here, down the middle of the box. And this, it says the figure below is a box plot. Box plots separate data into 4 parts. 1, 2, 3, and 4. Even though the parts may differ in length, each contains 25% of the data. The box shows the middle 50% of the data. Now, one thing that you need to know is over here with box plots, it says if the length of a whisker or the box is short, the values of the data in that part are concentrated. So if it's short, it's concentrated, which means the data is not spread out. If the length of a whisker or box is long, the values of the data in that part are spread out. So let's talk about that for a minute. This is really short. That means the data is not very spread out. The data is all really close together. Whereas this is way longer than this, or this is way longer than this. So is this first 25%. It's way longer than this. So the data in these sections are spread out farther than the data in this. This is more concentrated. It's not as spread out in this 25%. Now let's make one. Let's see this example here. By the way, before we talk about that, let's look at this. You may think that the median always divides the box in half. However, the median may not divide the box in half because the data may be clustered towards one quartile. So here it does kind of split it in half, but look down here. The median's not in the middle of this box. That's because the data here is more concentrated and it's more spread out in this section, this 25%, this quarter of the data is more spread out than this quarter of the data. All right, so draw a box plot of the car speed data. Step 1, order the numbers from least to greatest, then draw a number line that covers the range of the data. So let's order the numbers from least to greatest. Starting with, it looks like 19. So 19, then you got the 20s. So there's no 21, there's a 22. 23, 25, there are two 25s, and a 27. Now going into the 30s, 34, 35, and then 40. So the range of the data would be from 19 to 40. So the lower extreme is 19, the upper extreme is 40. Find the median, the first and third quartile. So the median, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this 25 is right in the middle. And then this half of the data, if you look on that side, 22 is in the middle. So that's quartile 1. And on this side, 34 is in the middle. So that's quartile 3. I still like to label everything. So you put the plots, the dots at all those points. Then you draw the box plot so it includes the quartile values. Draw a vertical line through the box at the median. Extend the whiskers. So let's draw the box up here. Quartile 1 to quartile 3, that's where the box goes. You draw a line for the median, and then the whiskers go out to the extremes. Now, in this case, there were not any outliers. So 19 to 40 was the range. All right, let's do one of these. And of course, they don't give us hardly any room. We love that. It says, draw a box plot of the data set below. So what we need to do is we need to order the data from least to greatest. Let's see, where do we start? 15s? So we have a couple 15s here. All right, there's a 17, an 18. Now going into the 20s, two 20s. All right, 22, 25, 27. So many pieces of data. Let's make sure we got them all. 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so now we have to find all of our measures of variation here. So there were 11. So if we go 5 on this side, 2, 3, 4, 5 on this side, This is our median. And our to the left, our first quartile in the middle there would be 17. And to the right of the median, 27 is in the middle. Now, are there going to be any outliers? Look at this. 27 and 30 are really close. 17 and 15 are really close. So there aren't going to be any outliers. So let's go ahead and decide what our scale is going to be here. We have 15, 30. What if we did 15, 20, 25, 30? 15, 20, 25, 30 on our number line. So let's mark the median at 20, 17, and 27. And I'm going to put a box around that right now with the line at the median. Now our little whiskers, 15 is the lower extreme and 30 is the upper extreme. So look at how this middle 50% of the data is more spread out than these end little whisker 25 here, 25% here of the data. It's more concentrated. Now that's what we're going to talk about when we interpret data. So how is it spread out? What's the median? What's the interquartile range? All things that you can interpret from a box plot. Though a box plot does not show individual data, you can use it to interpret data. So what it's saying is, this box plot here, it doesn't show all of these pieces of data in between, but it does show the main measures of variation, so we can interpret data with it. Refer to the box plot in example 1. So we're talking about this car speed one, and it says half of the drivers were driving faster than what speed? So half of the drivers. If this is 4/4, this would be half of the drivers that are faster than 25. So it says half of the 11 drivers were driving faster than 25 miles per hour. That's the speed. The median was 25. Half of them were faster than 25. What does the box plot's length tell about the data? So let's look at this first. What's more concentrated, what's more spread out? The drivers that drove less than 25 were more concentrated, so the bottom 50% is less spread out than this top 50% here. The data is more spread out there. And let's read this and see how they described it. The length of the left half of the box plot is short. This means that the speeds of the slowest half of the cars are concentrated. The speeds of the fastest half of the cars are spread out. And remember, when you forget that, the short is not spread out, long is spread out. You can always look back here. So we're going to do this problem here. What percent were driving faster than 34 miles per hour? So let's find 34 miles per hour. This much, so 1/4 of the data was faster. So that's 25%, right? 25% is 1/4 of the data. Now, let's do number 4. This is the example here. First, about outliers. We talked about this earlier. If the data set includes outliers, then the whiskers will not extend to the outliers, just to the previous data point. Outliers are represented with an asterisk on the box plot. So if we were to have had a number up here that was like really big, like 100, then that number would have been like a little asterisk on the box plot way over here. Because 100 definitely would have been an outlier. 27 minus 17 is 10. 10 times 1.5 is 15. So anything 15 more than 30 would have been an outlier. Okay. Now, back to this. So we need to find the median, the measures of variability, and describe the data spread. So the median right here is 72.5. The first quartile is 65. The third quartile is 80. The range is 54. Now, how'd they get that? The range is 90 minus whatever this is, 50 something. And the interquartile range, 80 minus 65, is 15. There is an outlier at 110. Both whiskers are approximately the same size. So the data without the outlier is spread evenly below and above the quartiles. Do you see that? The spread of each section is pretty much the same compared to this, where this spread was different from this spread. So the data is pretty evenly spread if you don't consider that outlier right there. That would change the spread. All right, we're going to try one of these together. So last practice together before the guided practice. The number of games won in the American Football Conference in a recent year is displayed below. Find the median and the measures of variability, then describe the data. So we need to find all of those measures of variation. The median is 8.5. So I'm going to write up here because I always write bigger than the space they give us. The median is 8.5. Q1 is what? 5.5. And Q2 is 11. So the inner quartile range is IQR 11, take away 5.5. So that would be 4.5. The range is, well, 13 minus 1, 12. And are there any outliers? No, there aren't any outliers. So I think we described all the measures of variation here: median, quartiles, range, and interquartile range. So now we have to talk about the spread. So how did they do that before? Let's look back at the example. Right here, the length of the left half is short. This means the speed of the slowest half is concentrated. The speeds of the fastest half are spread out. So what do we have more? We have the what is this, conference wins? The left side of the data is more spread out than the right side of the data. Okay, let's write that. So the first half, I'm going to call it, in parentheses, left side of the data is more spread out than the second half, in parentheses, right side of the data. So that is how you write a description, and you're going to have to do that type of stuff for the guided practice too. So it's time to find a partner and try some of this guided practice. So for guided practice, there are only 2 problems. In the first problem, you are going to be, just like examples 1 through 3, making a box plot, but like here, you're going to start to interpret it too. So there are, after you make this box plot, there are a couple questions to answer. And for number 2, there's a nice little spot to write a description of the measures of variation and the spread of the data here, just like we did up here. So with your partner, look back at the examples as needed. Complete number 1, watch the video, and then complete number 2 and watch the video. If you need help and you need to watch a little part of the video to get you started, that's totally fine. All right, here we go. This is number 1. So the first thing I need to do is order my data from least to greatest so I can get all of my measures of variation to make this box plot here. All right, it looks like 1 is our smallest number, and then there's a 2, a 3, a 4. 1, 2, 3 5s. No 6s, 2 7s. No 8s, 2 9s. A 10, an 11, and a 15. Let's make sure I got it all. 3, 6, 7, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, A half of 14 is 7. So 1, 2, 3, 4, 5, 6, 7. Right here. What's between 5 and 7? The median's going to be 6. All right, on this half of the data, what's in the middle? 4 is in the middle here. And on this half of the data, 9 is in the middle. So let's plot those. 4, 9, and the median is 6. Let's make a box around that and a line at the median. Now, are there any outliers here? Let's see, the interquartile range, 9 minus 4 is 5, and 5 times 1.5 is 7.5. So 7.5 less than 4 is negative. 7.5 more than 9, 12, 34, 16 is going to be above 15. So there aren't any outliers. So let's put 1 down here and 15 up here. Cool. Okay, what percent of the earthquakes were between 4 and 9 kilometers deep? 4 and 9. So what percent is this? That's 2 of the 4 quarters. So that would be 50%. And write a sentence explaining what the length of the box plot means. So the length of this box plot shows the range, right? The length of the box plot shows the range of how deep earthquakes are. And is it concentrated anywhere? It's more, the top half of the data is more spread out. A little bit, not too much though. So the length shows the range of depths of earthquakes. I would say it is pretty evenly spread. But the top half of the data is a bit more spread out. All right, let's move on to number 2. We need to interpret this. So we need to find the median, the measures of variability, and describe the data. So our median is 27 right there. Q1 and Q3 are 25 and 33. So the IQR is 33 minus 25, which is 8. The range would be, this is 40 minus 22. What is that, 18? Yep, 18. All right, there are no outliers, and the bottom half of the data is more concentrated. The top half of the data is more spread out. So let's write it. The median is 27. Q1 is 25, and Q3 is 33. So the interquartile range is 8. The range is 18, and there aren't any outliers. The bottom half of the data is concentrated, and the top half is more spread out. All right, man, we're doing a lot of writing in this lesson. Time to move on to the independent practice, where we'll do a couple more of these. Okay, so for the independent practice here, we are going to only do 2, 3, and 4. So number 2, you have to draw a box plot for this set of data. For number 3, you have to draw a box plot, and then you have to answer these questions. And then for number 4, you have to interpret the data in this box plot. So it's going to take a little bit of time. You can do it. All right, that was a lot of work. So let's see how we did here. I ordered data from least to greatest. Median right here was 113.5. Q1 95, Q3 162, and the low extreme was 55, the upper extreme was 174. Now when I did the IQR, I got 67 times 1.5 was 100, so there weren't any outliers. This greater than 100 was too much, and take away 100 from that was in the negatives, so there were no outliers. So just a simple box plot right there. Now there were outliers for number 3. So I ordered data from least to greatest, found the median, found Q1, and found Q3. So median 127, Q1 35.5, Q3 210. I took 210 minus 35.5 to get the IQR, multiplied that by 1.5 to get that magic product, and Q3 210 plus the magic product was 471, and there was a number greater than 471, so this was an outlier. Now down here, when you subtracted the magic number 261.75 from here, it was like way negative, so there wasn't an outlier on the left, but this was an outlier. So I plotted the lower extreme Q1, median Q3. This is the outlier, and then this is 301, which is the number before the outlier. Half of the states have a coastline less than how many miles? So half is here, and that was less than this median, which was 127 miles. And this was my sentence here describing the box plot. This bottom 25% was the only thing that was super concentrated compared to the rest. It was pretty evenly spread. Okay, so when you read this, you see the median here is at about 75. Q1 is at about 50, and Q3 is about 140. The interquartile range then would be 90, and then the range from this to this extreme is 400. There's an outlier at about 425. And if you look here, the first half of the data is more concentrated than the second half. The second half is more spread out. Now it's time for the reflection. All right, so I can draw and interpret box plots. On this box plot, label what each part represents. So just put the label on the line right here. And then use the box plot above to answer true or false. There are no outliers. The interquartile range is 40. The median is 40. The second quartile is more spread out than the third quartile. The fourth quartile is more spread out than the first. The outliers are 5 and 60. Draw a box plot over the number line below. So down here, you're going to draw a box plot to represent this data, and you're going to show your work right here. So you're going to have to order the numbers, calculate if there are any outliers. You should be good to go.